Okay, the purpose of this video is an introduction to C programming as used on the Arduino. It's a little bit of a scaled down C version, but what we want to do is talk about things that can change the flow of the program. Normally a program executes one instruction after another. Something has to kick it into a loop or down to another section. And that's what we're going to talk about today. These are very important in programming. Without loops and different things like that to change the flow, the program really isn't useful. So here we go. You see up on the screen right now is a website that I sort of like. It's called programiz.com. It gives a quick introduction, very simple introductions, and very clearly done with examples, and then has you write some examples to make sure you know what's going on. So we're going to talk about if-else statements. We're going to talk about for loops in C, while loops, and do while loops is under that subcategory. The break command, we'll talk about the continue later, and the switch and case statements. And we're going to do that by creating an example program. So first off, let's talk a little bit about the platform that we're going to be testing on. Let me drag this picture in here for you. This shows the setup that I'm using. I wrote a simple program and I needed some way to get numbers input. I didn't want to do that through the serial port. The serial port's going to be displaying certain lines depending on where we are in the code. So what you see in front of you is a really nifty setup. This is a shield that drops on top of or connects on top of the Arduino Uno board, and it's called a Grove shield. And it is a very simple way to, instead of running wires to each one of these little pins here to interface things, you buy these sensors, all kinds of different sensors. I think there's over 600 different sensors in the Grove library of parts. And some of them are analog sensors, some of them are digital I/O, and some of them are I2C. And there are different connectors in here to handle all those. Really just a simple way to make connections to your Arduino board. In this case, my setup is going to be use that Grove connector or that Grove shield board with all these connectors on the top. And we're going to hook a pot that is pulled up to 5 volts, and we're going to hook that on one of the analog inputs. So that's what you see there. Let me get that out of the way. If you want to go and take a look at the Grove sensors, you could go to CED Studio. And when you get there at CED Studio, if you go in the shop and choose Grove, you can get a feel for all the things that are available. And there's hundreds of these. It's only 16 per page. If I hit all, eventually it'll refresh and come up and show you all the different sensors that you can put on there and quickly attach with a cable. And the nice thing too is they provide all kinds of nice sensors and code and all that support till it's there. So it's pretty cool stuff. Okay, that gives us a good feel for what's available and what we're using in this thing. So what you see on the screen now is my code, and that code is going to implement some things from the program IZ site that you saw previously. So what I'm going to do is I'm just going to comment out certain parts of the code and only run certain parts at the time. So the very first thing we're going to look at is this top little section of the code. I have a pot that I'm reading the value from the pot. It's an analog input, so it's going to be somewhere between 0 and 1023. And as I turn that pot, is going to change that value. The reason I chose that is I had to have some way to change a number that I wanted to use throughout the program, and I didn't want to have to enter things in or interface anything that took a keyboard, and I thought a pot was the easiest way to do that. So we're going to read that value. That value is going to be stored in this variable called raw pot value. And then we're going to do a whole lot of stuff with the flow control instructions. So the first flow control instruction we're going to take a look at is the if statement. And you'll see here, right in this little section of code, we have if raw pot value is less than 10. And if that occurs, we're going to print out all this information about the pot, and that's going to come to the serial port or the serial monitor. So I have that up and running now, and you can see right now I have the pot twisted so that it is reading a value of 0. But if I change that value a little bit, and a little bit is sort of hard to do here, but if I change that value and see, now it's reading an 8, a 6, a 9 now that it finally settled down. 9 is awful close to 10, so it's jumping up above there a little bit, hitting that's there. So if I get it down just a little bit and we're reading 1 and 2 and 0, you'll see that these statements inside the if loop are always happening. And as soon as I get above 10, which is really easy to do, nothing inside of this loop is executing, and this serial print line statement up here outside of this loop is happening all the time. And that's how an if statement works. You should take a look at the Program IZ section on the if statement. They explain it pretty well, and our example code is pretty similar here. So I'm going to uncomment the rest of this code. This is pretty nifty if you've never done this before. If you fool around and you don't want part of the program to run, what you can do is select all that area and go to edit, and there's a comment, uncomment. So I commented all these lines. When I uncomment, all the code goes back to normal. I haven't downloaded it yet. And what I do is like to take a look at the next section of this code that I have in here, and it's the if else. So here is this part of the code deals with the if else. So what I'm going to do is I'm going to go up here, select all this code, and comment it out. I think I want to keep this. Yeah, I want to get that out of there. We still have to read the analog value, so I'm going to go to edit, comment, uncomment, and we want this if else statement, so that runs from there to there, and I'm going to select all this code down here and comment that out. So the only thing we have running in the program once I download it is the if else statement. And if we do this right, we won't get any compiler errors or things barking at me. So let me download this. While I'm busy downloading that, I'm going to clear the output on the serial monitor. And it's done uploading, and it's running the code once again. So I'm going to scroll back up here. This is the part of the code that we're dealing with now. Remember, we're still reading that pot value, and every time it loops around, and this is the only other thing in the loop. So the if-else statement, if I look at it, it's looking for if the raw pot value, the value I read in, if I divide it by 2 and I get a 0, that means I have an even number. Or else part of that, if it isn't even, that means it has to be odd. So what we're going to do is we're going to print this code in between here if it's an even number, and we're going to print this code if it's an odd number. And the only test for that is this raw pot value being divided by 2 and looking at the remainder. So if I go over here and I look at my value that's being read, switching back and forth between a 173 and 174, that has to do with the resolution of the analog input signal switching, but you can see 151 is the pot value I'm reading, and therefore it took the else part of this if else, and it's telling me it's an odd number. Now if I switch it, let's see if I get lucky enough to hit an even number. There we go, 138, 144. You'll notice now it's hitting the upper part, and it's printing out that it's an even number. So that shows you how an if-else statement works. Okay, this program is pretty simple. I'll make it available if you want it, but for now, I'm going to go in here and comment out that section. So the next thing that we want here is this if-else ladder. And really what that means is that we're going to have a whole slew of choices, not just even or odd that we did before. So let me uncomment this section. This is the only thing I have running now. Let me download the file again. And while it's downloading, let me clear the output. You'll notice that, let me make this a little bit bigger so we can see all the code. You'll notice at the top of each of these sections, I put a serial print line on here so we know which section it's working on. And that helps me work as we go along. So you can have more than one else, and the format is if, and you have a condition. Else, you can put in a second condition. And the third else would be, if it isn't those two, it has to be this. And they call that an if-else ladder. At least that's what this programming text calls it. And it's pretty cool. So it looks to me like the first condition we have set up said if it's equal to 10, I print it's equal to 10. If it's greater than 10, it would fall in here. So equal and greater, the only thing we have left in this else statement is the less than. So if I go over here, I have my pot dialed in, so it's 138 right now. And I go the wrong way, went to 1023. But if I go down to 0, you can see that we're hitting the part of the code that says it's less than 10. I don't. Oh, there we did get one that said it's equal to 10 as I changed. 5 is less than 10, and 39 is greater than 10. So you can see it's reading this raw pot value from the pot's analog input port on the thing, and I'm choosing one of these conditions based on the if, else, if, and else. So that's a syntax that you can remember. It's a different way to adjust the flow control. Okay, let me choose this code now and get rid of that or comment it out. This comment uncomment is a pretty nice feature. Now it says nested if, and this is one that you're going to have to study a little bit on your own, but that's undo it as far as comments go. So I'm going to uncomment all those lines. I'm going to run my code, and luckily I've been doing pretty good. I haven't messed my program up as long as I go. So now you'll notice that the serial port is responding to this portion of the code. And if you look at this portion of code, there's an if statement that says if the raw pot value is greater than or equal to 10. But right within that, I have another if statement, which is nested. And it's an if within an if. And it says if it got in here, it could be greater than or equal to 10. Okay. Then it says if the raw pot value is equal to 0, which I probably think that should be equal to 10. I think I have a code problem there. Let me download that. If it's equal to 10, it's going to print out it's equal. And that nested if within there says that else part of that is it's greater than 10, because we know that the only way that it could be in here and in this if statement if it's greater than or equal to 10. So that's a nested if statement, an if within an if. And when I say nested if statement, it could be if else or if else ladder or all that stuff. And then down here is the else part of the if. So the only way it gets down here is if this is less than 10. And you can see in this case the else conditions that we're printing out if it's less than 10. And we could play with the pot and watch the output values to test that, to say that's how it works. So that gets you all the different variations of an if else statement. And let's comment those back. I'm messing up my indentations a little bit, so we'll fix them as we go along. So the next thing that we want to take a look at, the next way to change a loop structure, is for loop. And if I go in here, and this is the end of the for loop demo, and we have a for loop in here. I guess it's right here is where I want to uncomment. And I send that code down. And once again, I clear my output so I can see what's happening here. What you can see now is let me stop the auto scroll because it goes too fast. I want to just get a simple loop demo. And what it's really doing is showing me the current value, which is I, changing within the for loop. So you can see here with the for loop, we set up the initial value for I. That is assigned once right at the beginning of the for loop. The condition to stay in the for loop, and that's I is less than 11. And then the condition that happens right at the end of the for loop, which is we add 1 to I. So as this for loop executes and goes through its whole thing, it's adding 1 to I each time. But these serial print and print line commands send the value out to the serial port to tell you the current value of I. So you're going to get current value of I as 1. Then you're going to do I++, go back up through here, check if I is less than 11. If it is, you're going to print out for current value of 2. Then add 1 to I, that'll be 3. And that's going to go the whole way until it gets up here where I is not less than 11. When that condition is not true, and when that's not true, it drops out of the loop. So that works pretty well. I think it's shown pretty clearly in the code and actually at the display that you see here. So I'm going to comment that back out again. And perhaps, let me make sure I'm not making any errors in here. The next thing down here is a for loop demo. And this time, the loop is pretty much the same. I'm not going to uncomment this one. We'll just quickly talk about it. But you see in this case, the for loop is, instead of printing out the value, we're going to have what they call a count value. And that count value is going to be less than or equal to 10. That's our condition to stop the for loop. And we're going to add 1 to the count value. At this time in the middle, what we're going to do is keep the sum of the current numbers that are there. So sum of sum plus count is going to say 1 plus 2 is equal to 3 plus 4, and it's going to keep on adding those numbers up until you're there. And then we're not going to print out that result until after we exit the for loop. So that you can see that you can do other things than just use the variable that sets up the loop counter within the loop to do stuff. So that gives you a good idea of the for loops and how they work. There's a while loop here. That's another structure that occurs within the Arduino world. And you can look here and see that in the while loop, what we do is set a value. In this case, I is equal to 1. And while I is less than or equal to 5, I'm going to stay inside this loop. So you never get in this while loop unless I is less than or equal to 5. You stay in this while loop and do all these things within the while structure until this condition isn't true. So I keep on adding 1 to that, and as I go along here, I'm going to print the current value out, and it's going to end up that when this gets to a 5, I is going to be still less than equal to, that's okay. I'm going to print that out. And when this gets to a 6, I'm going to get back up here to this condition, and I'm going to jump out of there. Uh, while loops have 2 variations. One where you test ahead of time and you don't get in the loop, so it's possible you don't even execute it one time. And then it has this variation of do while. And what happens here is we don't check for the condition to get out of the loop until the end. And that means that the do while loop is used where you want to do something at least one time. The while loop, you want to check and you might not even want to do it one time. And it's there. And there are specific times when you look at code or a solution to write a loop that you're going to use a do while loop instead of a while loop. Once again, the Program IZ website does explain this pretty well. So the last thing that I want to hit here in this video, as it gets a little bit longer than I wanted it to, is the switch demo. So I'm going to go down here, and this is what programmers would usually call a case statement. It just so happens in C programming, the name of the statement is a switch. So I'm going to uncomment that. I think I have that correct without messing too many things up. I'm going to clear my output. And now what we're going to see, I'm going to put auto scroll on again, and you're going to see a lot of messages pounding out here. So if I stop the auto scroll and I go back to the switch statement, what I'm doing is checking this raw point value, and I'm giving it certain cases. In case 0, 1, 2, 3, 4, and 5. So what happens is in this switch statement, I get this raw point value, and if that raw pot value, I'm sorry, is 0, I'm going to print out that pot value is 0. If it's 1, I'm going to print out it's 1, and if it's 2, I'm going to print out 2. And with the case statement, you have to cover all the possible values for raw pot value. That's 0 to 1023. And I don't want to have that many different ones. So the way I cover it is I cover 0 through 4, and then the default condition would take care of 5 through 1023. The common error that you get in C with using the switch and the different defining the different cases is that once this case statement is executes, once it jumps to here, because the value is a 3 and it would jump the whole way down to here, it would do these 2 commands, and without this break statement, it would actually just continue to execute these commands down through here. So this break jumps out of the switch statement and goes outside of the switch loop. So these breaks are required inside of each case situation that's there. You'll notice the default situation, which handles all the other values, it does not have to have a break statement because it's at the end of the command, so there's no other code to execute after that. And if we look at the output, it probably scrolls a little bit too fast to be very useful, which means I probably should have put some more delays in the program so we'd slow it down. But you can see that it's hitting each of these case statements as it goes through. So hopefully with this program and being able to work with it on your own and fool around with it and look at the output serial monitor output, you can understand how these basic flow control structures work. And that is all the flow control that you have in a C program. I guess there's a go-to statement that we haven't shown either. So hopefully that was helpful. Sorry to run your time out a little bit, but we had a lot of topics here, and hopefully that gives you a good idea of what's happening with flow control and what I want to change. Talk to you the next time.